Wouldn't it be great if there was a way to reference a method and be able to invoke that method without it being a part of the current scope? Welcome to the module where we are going to talk in detail about using delegates and lambdas. You're watching the course C# Advanced Language Features, and I'm Philip Ekberg. A delegate in C# looks and acts very much like a traditional function pointer that you may have seen or heard about from other programming languages. A traditional function pointer is exactly what it sounds like, a way to point to a particular method. You could have a method that accepts a function pointer so that you have a way to extend its behavior or receive a callback when that method completes. In C#, a function pointer is known as a delegate. However, out of the box, the C# delegate provides a bit more functionality. Throughout this module, you will learn about the delegate keyword, action, action of t, func of t, and lambdas. First, let's go through the delegate. Think of a delegate as a way to represent the required method signature. Whenever you define that you want to use a delegate, the consumer of the delegate knows exactly what the function you will point to will return, as well as what the expected parameters are. You can construct a delegate by introducing the delegate keyword. You then proceed to declare the method signature. For example, here's a delegate that returns an order instance and has two parameters. One of them is item, and the second parameter is an integer representing the quantity. Nothing in this declaration defines what the method will do with its parameters or what result it will return. These two different methods both match the signature defined by the delegate. One defines that it returns an order, while the other returns a subclass type called processed order. The return type supports covariance, while the delegate parameter supports contravariance. This means a method with the return type object wouldn't match our defined delegate, as you cannot use a less derived object when matching the return type. On the other hand, since the parameters support contravariance, you can change the item parameter to object, and that would work. The delegate can then be referenced throughout the application using its name. This means that whenever we declare that we want to use this defined delegate, both of these methods could be viable references. Whoever uses the delegate doesn't need to care about the implementation. All it knows about is the return type and the parameters. Let's explore exactly how this works throughout this module. Being able to reference and invoke a method without that method being a part of the scope or class that you are interacting with opens up a lot of potential possibilities. In essence, the work is being delegated somewhere else. Let's talk about a few common use cases for delegates. Use it to receive a callback when a certain operation completes. This was a lot more common in the past, where you might have executed work on a separate thread, and after that work completed, you wanted to execute a particular method. This is where you'd introduce a callback and pass a reference to that method, also known as using a delegate. In user interface programming, such as WPF, WinForms, Xamarin, .NET MAUI, to name a few, you very often rely on something called events. This will be thoroughly covered in the next module. But this builds on top of delegates. When you press a button on your user interface, a method should be executed. To implement the handler for that event, you need to correspond to the delegate signature. This method is then being referenced by using a delegate. Another common use case is extensibility. You can provide a way to replace or extend functionality of your classes without requiring them to be subclassed. In our example application that handles everything inside a warehouse, a good example of this is where the order is being processed. This is done inside the business layer and may be used across multiple different applications in the business. These applications may all want to inject functionality to run when the order starts being processed, as well as when the order processing completes. This could be used in many ways. One of them could be how you are producing the shipping label after the order is processed, or even how the order confirmation is being sent. The exact functionality could be decided and replaced in runtime by simply passing a reference to a method that matches the given delegate. You will notice that some libraries in .NET, as well as some that you install from NuGet, will provide you with the capability to inject functionality. Some even depend on it. This could be everything from determining sort order when sorting an array of elements to callbacks. In this scenario, being able to pass a reference to that method is really handy. Where you decide to use delegates in your applications may, of course, vary. Being able to provide a way to extend or replace functionality at runtime is going to prove very powerful. We will also highlight where this may cause potential problems. As with any language feature, you should completely understand its purpose and the potential problems that you may run into. The tools of the language are here to help you, but use it where it's appropriate and think about how it architecturally fits in your application. With a bit of background and a peek at what a delegate declaration looks like, let's proceed to construct a delegate and invoke that in our application.